One of the newest projects we have that we've been working on for a few years and just got funded by this grant from the National Institute on Alcohol Abuse is to actually try to develop these novel molecules that actually can break up a protein-protein interaction. And one of the proteins is actually this protein that binds this hormone known as corticotrophin-releasing factor, or CRF. Now that's the main hormone in your body that actually controls the stress axis. When you have a major stressor, this hormone is released from a very particular part of the brain and eventually causes the release of cortisol in the periphery that causes the stress response. There's been a lot of efforts to try to develop ways to block the action of this hormone known as CRF in the brain. And there's two receptors that mediate the actions of this particular hormone. They come together in a very special way in certain parts of the brain. And if you actually can block that ability of those two proteins to interact, you actually can minimize the overall stress that you actually see from that particular receptor. Out of all of that 400,000 compounds, we found 3. There were 3 compounds that looked like they were really doing something unique. And those compounds started as the basis of all the work I've done on CRF receptors ever since then for the last 7 or 8 years. We're essentially in what we would call lead optimization at this point. So we've identified these novel chemical scaffolds that do what we think they should be doing. And we're trying to understand chemical modifications on these scaffolds that will allow us to improve their properties so that, you could take a lower amount of the drug and it actually has a higher exposure in the body. We're trying to get to what we would call a lead candidate that we would then start to do preclinical studies on to try to get to eventually to man. So we're probably 6 years, 7 years away from maybe getting to the clinic for these. With a lot of these projects, they're all similar. You're trying to fight 2 different aspects of addiction. And one of the things we hope, especially for the mGlu2 PAM program that Nick Koster was speaking about earlier, that drug in preclinical models actually works really well to minimize drug craving in animals. This particular receptor that program is targeting, it's actually expressed in all the right brain regions that are involved in emotional and cognitive control. It's also expressed in a lot of the different pathways in what's called the reward pathway, which is really what essentially the whole pathway drives how we get rewarded for something that we should naturally get rewarded for. If we could eventually get approval to treat nicotine with this drug, it would be very easy at that point to go back and run. You already have an approved medication for an abuse disorder. You would have to go back and run a different phase 2 clinical trial under a different indication. You can amend the existing new drug application to do that, and it's something that could be very readily done. And that's part of why in the background we're working on these types of drugs and whether or not they work in opiate use disorder, methamphetamine use disorder, actually combination methamphetamine and opioid use disorder, alcohol abuse, everything else under the sun. We're just looking across the board, and thus far they seem like they're working preclinically in every model we've tried.